Hello, everyone. Okay, now in this lecture, well, I'm going to talk about section 2.4 and 2.5. But before I start that section, I just want to talk a little bit about exam one. So the exam one is going to be this Wednesday. I think you all know about that right by now, because the exam one is Wednesday, which is, I think, June 10. All right, so it will be over section from 1.1, basically all section from chapter 1, 1.1 to 1.6, and also 2.1, and the today's section 2.4 and 2.5. All right. And the thing is, if you see our tentative schedule, I think this section is not there. This section is not there. And now if you go and check now the updated schedule, because I updated the schedule and I've included this section to the schedule. So now if you see this updated schedule, you will see this section, all right? And this section will also be the part of exam one, okay? So you can see the updated schedule and the Blackboard inside the information tab. And in there, you'll see the new updated one, all right? So please check it over there. So if I do any changes, I'll let you guys know. But yeah, right now I made a changes. So the new change is, yeah, these two sections are included now. All right. So, okay. So also I have, so this was due Sunday, right? This was due Sunday, which you guys have already done it. Now these three sections, 2.1, 2.4, and 2.5 will be due the exam day, Wednesday, by 11:59 p.m. All right. Okay. I think that's all I want to talk about the exam. Okay. So yeah. So the exam I will. Okay, I can show it here again. The exam I will upload the exam here. Here. And the quiz and exam. So you'll see there. And I will open the exam. So you will be able to see the exam on Wednesday from 12 a.m. at night. The same day, 12:59 p.m. It will be just like the time interval is just like the quiz. So you will get 24 hours time. So which I think 24 hours is enough time. Even though you work, you can still do the exam after you're done with your work. So just manage your time however you want to do it that day. So it will be open this time. Okay. So I don't think there should be any trouble with the timing, because 24 hours, I'm giving you enough time. All right. Okay. So did I say this is for homework? So yeah, this is about the Pearson homework. Okay. This is the Pearson homework, which will be due Wednesday, 11:59 p.m. Right. Okay. Now let's go to the section 2.4 and 2.5. All right. So the section 2.4 and 2.5 is about, well, we are going to talk about the derivative here. This section is about the derivative. All right. Now, before we go and define the derivative, I just want to talk a few things about the ideas of the derivative. So the first, well, I'm going to start with the slope. So yeah, we have talked about this, and probably you guys have done this in the college algebra or algebra course. So a line is given, and we have 2 points. All right, we have 2 points, and let's say we know, well, if I want to find the slope of this line, the slope is basically the idea of the slope is vertical change over horizontal change, right? So if you see this graph, this is called vertical change, or let me just write VC, vertical change, and this is a horizontal change, or let's just say HC, right? And let's say this horizontal change, this value is H. Let's just assume that. All right, all right, all right, all right. We don't. All right. Now, if I say this point is, let's say this point is, okay, first let's just name this line f of x line, right? If this line is f of x line, then, okay, let's say this point here is a. If the x value is a, then since this is f of x line, then the y value is f of a, right? And as I said that this horizontal change is h, so this new point here, since this point is a, then the new point here must be a plus h, right? So a plus h is the x, and the y must be f of a plus h, right? So this is a new point. So a plus h is x, and f of a plus h is y. Okay, so now, yeah, this is how we are going to define 2 points on the line. All right, so using, using these 2 points, well, I can say, if I want to use this formula, y2 minus y1 over x2 minus x1, then I can assume this x1, y1, this x2, y2. So the x2 is a plus h, and y2 is f of a plus h. All right, and here x1 is just a, and y1 is f of a. All right, so from here, using this now, this formula, slope, we get slope is equals to y2 is, we said y2 is f of a plus h minus y1 is f of a, right? Over x2 is a plus h minus x1 is a. All right, so if you notice here on the denominator, we have a minus a, which will cancel. So this is going to be just f of a plus h minus f of a over just h. All right, so the slope with this line, with these 2 points on the line, we can say slope is this. And also slope, we can also say the slope is, well, since you are saying vertical change over horizontal change, all right, so we are finding vertical change over horizontal change, so we can also say the slope is average, A-V-E-R-A-G, average, right? Average rate of change. All right, so, okay, so the average rate of change, or if you see a problem asking average rate of change, or if you see slope, then yeah, this is a formula right here, okay? And, okay, so the next one is, okay, let's go to the next page. Okay, let's say we have a parabola, something like this, and there is a line. This line crosses this graph here and here, okay? And let's just name this point, let's say again, a comma f of a. and this point, let's say, just like we did before, this is a plus h, comma f of a plus h. All right. So since this line crosses this parabola twice, so this kind of line, we say a second line. All right. All right. So here, okay. So as we said that, let me draw this in different color. As we said that this h is right here, right? We say h is, this value is h, right? So, okay, so here now let's see. Well, we're seeing this whole line, this line here, we said h, but let's say if h approaches towards 0. So let's say if h approaches towards 0, which means here h value is going to be 0. And this line, well, we know this second line goes through 2 points. Now, if this h approaches towards 0, that means this point is also going to approach towards this point. All right, so here we are going to get, if that's the case, then we are going to get a line that just touch this point. If h approaches towards 0, if h is going to be towards 0, if it's going to go towards 0, then yeah, that will get a line that just now touches just once here at one point. So these kind of line we say tangent line. All right. Okay, so for this line, we said that for this line, the slope is, we said before here, right? We said before for this line, the slope is this, right? F of a plus h minus f of a over h, right? Now for tangent line, the slope of the tangent line is going to be when h approaches towards 0. So for approaching things, we introduce a limit, right? I said that on section 2.1. So we can also rewrite these kind of things saying limit where h approaches towards 0. So when h approaches towards 0, we find the slope of a tangent line. All right, so these kind of slope we say, well, slope of a tangent line, or we can also say instantaneous rate of change. Rate of change. Right, so instantaneous rate of change is also, well, yeah, this means a slope of a tangent line at this point, because since this line is touching just at this point, so we say a slope of a line at this point. All right. Okay, now, okay, so now, okay, now using this idea, now finally we can define a derivative. Okay, so now the derivative, so now the derivative, the definition of derivative, let's just write the definition. Let me just write DEF, and this means definition. The definition of the derivative is now, let's say if we have, let's say if we have y is equals to f of x, a function, then we can say the derivative of this function, f function of f at x. The reason we have x here is because I have this f in terms of x, right? So the derivative of f at x, which I can also write f to the power, well, something like 1, but this is not 1. We say f prime, all right? We don't say f to the power 1. We just say f prime of x. So the derivative, we can write the derivative notation like this, okay? So the derivative notation, derivative means it is also similar to the slope of a tangent line at that point, at a certain point. So here we have x, so yeah, the slope of a tangent line at this point, okay? So here we will get this, the same thing that we got here for this one, all right? So the limit where h goes to 0, f of a plus h minus f of a over h. All right, so this is how we write, or this is how we define the derivative. All right, so the derivative of certain function, we can take the derivative using this limit. All right, so now I can say, well, since we are saying this is equals to this, so this exists, so this exists. The only time this exists if this thing exists, right? Because if the limit doesn't exist, that means the derivative doesn't exist. So if you get something, if this one exists, if you get some value from here, if this limit exists, then we can also say this exists, right? Okay, so now let's do an example here. Let's do an example. So the example here is f of x is equals to 2 minus 3x squared. All right, so 2 minus 3x squared. So I want to take the derivative of this. So the derivative, so the derivative, I want to find the value of the derivative, means I want to find this value, f prime of x. All right, so I want to find f prime of x, this one. All right, so the way we need to find this, well, if you sum up everything here, let me just rewrite this in 4 steps. So here we need to, so if I want to find the derivative of f of x, that means I want to find the value of this whole thing. But let's just simplify, or let's just write this in a simple form. Let's just break this into 4 steps. So if you remember these 4 steps, then it will be easy for you to follow the steps to get the f prime. All right, so now the first one we need here is we need to find f of x plus h. So we know the f of x is given. Now I need to find the f of x plus h. All right, the first one is that. The second one is now find f of x plus h. Once you find the value of that, f of x plus h minus f of x. Okay. Okay, one thing I forgot here. So since I'm saying f of x, since I have x here, I need to replace this a by x, because this is now it's a function of x. So I should have here x as well. All right. If I say f, if this function is f of a, then in that case there will be a here. But since I'm saying f of x here, so that means the derivative of f of x must be x here as well. All right. Okay, so now the third one here, is f of x plus h minus f of x over h. And the fourth one is taking the limit of this whole thing, right? So the limit where h goes to 0 of f of x plus h minus f of x over h. All right, so yeah, to find the derivative, follow these 4 steps. All right, if you remember these 4 steps, then yeah, it'll be easy to find the value of f prime of x. So now let's find the derivative of this. So let's find this f prime of x. All right. So now to find the f prime of x, the first one we're going to do here is find the value of this f of x plus h. So as we know, well, since we know f of x is this, so if I change this x to x plus h, if I change this x to x plus h, then I need to change here this x to x plus h as well, right? So this x will be x plus h, and still have this power too, right? And then after this, 2 minus, well, x plus h square is also a plus b whole square is also a square plus 2ab plus b square. This is a formula, right? I hope you guys know this. If not, it's right here. Just memorize this formula. All right. So now if we have a plus b whole square means a square plus 2b plus b square. So here we get a square or x square plus 2ab xh plus h square. So 2 minus x square. I'm going to distribute this negative 3 to all of these. Minus negative, negative 3 times this is negative 6 xh and negative 3 h square, right? Okay, the first one we got that. Now the second one is now find the value of this whole thing. All right, so now f of x plus h minus f of x is equals to, well, f of x plus h, I got it right here. So 2 minus 3x square minus 6xh minus 3h square minus f of x is, well, f of x is given right here. So remember that there is a minus here as well. So you need to distribute this minus to both of these, right? So the first one will stay minus 2. This minus will give plus 3x square. All right, so here we see we can cancel something. So 2 minus 2, gone. Negative 3x square, positive 3x square, gone. So here we just have, now we just have, these negative 6xh minus 3h square. So here I have h here, so I can factor out h, and also I can factor out, these two are gone, right? So I can factor out negative as well, because I have a negative here. So negative, and also I can factor, let me just write it first here so it will be easy to see. Okay, so here if I write this here again, the remaining terms. So now first I can factor out, I have first negative, let's just factor out that. I have a 6, 3, so let's factor out 3, and I have h squared, so let's factor out h. If I factor out these things, then we get here 2x plus 3h. Sorry, just h. Here, just h. Right? So then, okay, so we got the second part. Now the third part is, now once we get the value of this, the third part is divide that value by h. So I can divide the third one. I can, let me just write it here. Third one divide by h, right? And the fourth one, take the limit of this, right? Take the limit of this. So that means, let me write it in the next page. The limit where h goes to 0 for negative 3h, 2x plus h over h, negative 3h. Okay, negative 3h, 2x plus h over h, right? Yeah, 2x plus h, right? Yeah. So now here, it looks like now I can also cancel these two h, right? H on the top, h on the bottom goes out. Now we just have, since, well, this we can say this is the limit. Sorry, this is the derivative of f in terms of x, right? So this is also, now I just get limit of h goes to 0, negative 3 2x plus h. So now on this kind of equation, now I can say that since h goes to 0, that means this h is also going to goes to 0. So now I can get rid of this limit. So if I say h goes to 0, then I get negative 3 times 2x plus 0, which will give negative 6x, because this is gone, right? So this is the derivative. All right. So yeah, I can find the derivative of a function, given function, using the definition of the derivative. All right. So all I'm doing here is just using the definition. Okay. So this is basically the idea of section 2.4. All right. So now let's go to section 2.5. So section 2.5 is about different properties. Properties of derivatives. So we'll see different ways of writing or finding derivative. All right. So first, let's say, again, if I have, let's say y is equals to f of x, then the way we write the derivative here, we said the derivative of this, we write f of f inverse of x, right? Or you can also, instead of saying this, since I said y is equals to f of x here, so if you have something like this, I can also say just y prime. So f prime of x, or y prime, or I can also say this dy over dx. So here, this means I'm taking the derivative of y in terms of x. So if I write dy over dx, this also says the derivative of this function. Or I can also simply say, or not simply, but I can also say d of f of x, because since I said y is equals to f of x, instead of writing y, I can write d of f of x over d of x. All right, so these are the different ways you can write the derivative. All right, so all of these means the derivative. All right, so now let's see another property, power rule. Okay, so again, let's say if I have y is equals to f of x, and this f of x now, let's say, is x to the power of some number, x to the power, let's just say n. All right, now finding the derivative of this kind of function. So the derivative here, let's just say y prime. is equals to, using the power rule here, there is a rule, power rule. Using the power rule, I can say, I can bring this n down here. So n times x to the power. Now we are going to get new power, which will be n minus 1. All right, so this is a power rule. So now using this power rule, I can do a lot of things here. Let me just check one thing if I misses something from 2.5. Yes. Yeah, that's the main thing. Okay, now using this power rule, let's do some examples. So I'll be doing like 7 or 8 examples here. All right, so and you will see these kind of thing in the exams for sure. Well, maybe not the same thing, but the idea of these will be there in the exams. All right, so first one, let's say the first one, let's say is f of x is equals to x to the power 3. So I said that if I want to find the derivative of this, I can just write f prime of x is equals to, now using the power rule, using this power rule, I can bring this power down here, and now I will get the new power after that. Okay, that's called the derivative. So that means I can bring this 3 down here, and then x to the power 3 minus 1, which is also 3 times x to the power 2. All right, so this is the derivative of this function. All right. The second one, let's say f of x is equals to x to the power -4. All right, now we have a negative number on the top. Still same thing, we have to follow the same process. F of x, sorry, f prime of x is equals to, I'm going to bring this whole thing, -4, down here. So -4, x to the power -4, right? Because the n here, we're considering n is -4. So -4 minus 1. All right, so this is also now -4, x to the power -5, right? All right, so now after this, x to the power -5 is also 1 over x to the power +5, right? This is algebra, right? 1 over negative number is also equals to 1 over x to the power, that number, but with the positive sign. Okay, now I can rewrite this as like this, -4 over x to the power +5, right? Now this third problem, let's say f of x is equals to x to the power 3 over 2. All right, so here, again, I can say f prime of x is equals to, now I have this fraction on the top, so I can bring this whole thing, fraction, down here, 3 over 2, x to the power 3 over 2 minus 1, which is also equals to 3 over 2. So x to the power 3 over 2 minus 1 is 1 over 2, right? And this is also equals to 3 over 2. X to the power 1/2, also right, square root of x, right? Okay, now third one. Oh, sorry, yeah, fourth one. Yeah, the fourth one is now, let's say, f of x is equals to a number or some constant. Instead of writing 3, well, there could be any number here. All right, so let's just say constant. if I want to take the derivative of a constant, then the derivative of a constant is always 0. All right. And you can now take this as another property. All right. So derivative of a constant is always 0. Okay. And another one. So now let's say, okay, let's find, okay, let's write this first. So f of x is equals to 4 times x to the power 7. All right, now on this problem, there was a variable and something in the power, but there was nothing in the front, right? But now I have something in the front, some number. So in this kind of case, so let's just explain something here. So if I have f of x is equals to some number, some constant, some number times some equation, which is similar to this condition, right? I have some number with some equation. Then in this kind of case, if I want to take the derivative of this, since these two are multiplying here, right? So if these two are multiplying, then in this case, we are going to say that this thing on the front is going to stay there. It will not change. Now I just have to take the derivative of this variable part. All right. So using this idea, I can say here again, f prime of x is equals to this thing. Since these two are multiplying, well, here we have just a number, right? So if you're taking just a number, or if you're taking just the derivative of a number, this is a 0. But here, this number is attached, or this number is multiplied with a variable. So in this case, we cannot just say this is equals to 0. That's not possible. So we have to, this part is just going to stay there. This will not change. Now just take the derivative of this x to the power 7. So if I take the derivative of x to the power 7 using that power rule, then this 7 is going to come down here, right? So that will make 4 times 7 and x to the power 7 minus 1, right? So this will give 7 times 4 is 28 and x to the power 6. Okay. Now the next one, okay, so the next one, f of x is equals to, it's x to the power 4 minus 3x to the power 7 plus 9x plus 4. All right, so now I want to take the derivative of this whole thing. All right, so if I want to take the derivative of this whole thing, okay, so now I have this minus this, now plus. So I have like 4 terms here, right? So here in this kind of case, what we're going to do is, okay, so if I have f of x is equals to something, let's just say h of x plus g of x, and if I want to take the derivative of this, then the derivative of f of x, oops, what happened there? Will be the derivative of these each terms, h of derivative of h of x and derivative of g of x. Okay, so we got to do something here. So if I want to take the derivative of this f of x, I have to take the derivative of this each single term. So here, x to the power 4, well, if I take the derivative of this, 4 is going to come down here, and x to the power 4 minus 1, there's a minus here, minus. Okay, this 3 is multiplied with this x to the power 7, so this 3 will stay there, like I did here. Okay, so 3 will stay there, and I just have to bring the 7 down here, and x to the power 7 minus 1 plus 9 And here on the top, even though we don't write, there is always 1 on the top. Okay, so then I can bring this 1 down here, which will not make any difference. So 9 times 1 is still 9, and x to the power 1 minus 1, right? Is this 1 minus 1 using the power rule, plus the derivative of a constant or number is always 0, like I said here. Okay, now the derivative is now going to be 4 times x to the power 3, 7 times 3, 21, x to the power 6 plus 9x. There you go. That's the derivative of this function. Okay. Let me do one more problem. Yeah, let me do one more problem. One more problem with one more ideas as well here. So let's say now I have another one. Let's say, I think this is g. F of x is equals to 1 plus x to the power 3 over x to the power, let's say this x to the power 5 or x to the power 3. All right, so let's find the derivative of these kind of functions. So x plus, 1 plus x to the power 5 over x to the power 3. Okay, so now here, before I take the derivative of this, let's simplify this function so it will be easy to take the derivative. Just right now, taking the derivative of this is impossible based on what we have talked so far. All right, based on what we have talked so far, well, we cannot take the derivative of this. But what we can do is we can simplify this, and then after that, we can take the derivative of this. Okay, so here I can also write this as 1 over x to the power 1 over x to the power 3 plus x to the power 5 over x to the power 3, right? I can say this, these two are same thing. And also after this, I can say that this is also, well, x to the power 5 over x to the power 3 is just x to the power 2. And also I can move this to the top, which will be x to the power negative 3 plus x to the power 2. All right, there you go. Now it's easy, right? Now after this, I can take the derivative of this. Now I don't have any fraction like this. So now I can take the derivative of these two separately. So the first one, like if I take the derivative of this negative 3 is going to come to the front, x to the power negative 3 minus 1 plus 2 to the front, and x to the power 2 minus 1. So this will give negative 3x to the power negative 4 plus 2 times x, just x, right? X to the power 1 or just x. Also, I can rewrite this. So if I move this thing to the bottom, then it will be negative 3 over x to the power now positive 4 plus 2x. All right, so now this is the derivative of this function. All right. Okay, so now the next one, what I want to talk about here is, let's say I have a function given f of x is equals to, let's just say a random function, 3x to the power 2 plus 4x plus 7, something like this. Now a problem is asking to, well, you to find the instantaneous, let's say it is asking you to get the instantaneous velocity function, which also means v. right? So velocity function, instantaneous velocity function is also called v. So now the way to find this is basically here. Again, it's the same thing. The v is, well, here, if you want to find the velocity function of this function, f of x, then this v is also same as f prime of x. Okay. So yeah, that's the idea. Okay. So yeah, I just want to talk this much for this section. All right. So yeah. So whatever I have covered so far, till section 2.5, it will be a part of exam 1. So you need to know everything that I've talked so far till section 2.5 for exam 1. All right. See you on the next next lecture, and good luck for exam. Thank you.